Welcome experts and enthusiasts of renewable energy around the world. Today we will recycle a washing machine motor from an old top loader into a wind turbine generator. First is to detach the direct drive AC motor block from the aluminum washing tub casing using a Habotest digital multimeter to measure the resistance and identify the coils. 3. Measuring the wire pairs helps us accurately distinguish the run and start windings of the stator. 3. Connect the AC power sources to the corresponding terminals to test operation. 4. Upon supplying power, the motor shaft spins very smoothly, proving the magnetic coil system is still perfect. 1. Proceed to clean the surface and use a specialized socket wrench to remove the central shaft locking nut. 2. Remove the zinc-plated pulley or heatsink to prepare for accessing the motor core. 3. Remove the protective plastic cover underneath. This part is normally used to prevent water leaks from the washing tub. The outer galvanized metal shell is quite severely oxidized and rusted. Use a handheld angle grinder to grind off and cut the rivet heads, connecting the two half covers. To completely dismantle it, use a cordless drill to break right into the core of the stubborn metal rivets. Successfully separate the front and rear covers. We can clearly see the stator assembly with its copper coils. Gently pull the squirrel cage rotor out. The amount of copper in the stator is still very good, with no short circuits. Clamp the stator block firmly into the bench vise. Switch to an angle grinder fitted with a wire brush to remove the rust layer on the electrical steel core to optimize surface magnetic flux efficiency. Move on to processing the rotor. The dirt on the bearings needs to be deep cleaned with WD-40 rust remover. After cleaning, apply lithium-based lubricating grease, red-colored for high heat and high friction resistance. Close the rubber seal to protect the bearing and wipe clean the excess grease around the metal shaft. 4. Check that the bearing spins extremely smoothly to ensure minimal friction-induced kinetic energy loss. 5. Use fine sandpaper to polish the tip of the rotor shaft, which is yellowing, to restore the metal surface. 6. Spray an extra coating of WD-40 to protect the steel from re-oxidizing in an open environment. Step 1. A breakthrough step in modifying the original squirrel cage rotor by adding magnetic core positioning pins. Step 2. The creator creatively uses a 12 volts car battery to set up a manual spot welder. 4. Clamp the negative terminal to the shaft body. Poke the positive terminal onto the pin to create a highly intense thermal arc for spot welding. This poke welding technique makes the pin stick firmly to the rotor. Continue removing rust from the motor flange cover. 4. Move on to the stage of applying protective epoxy paint. A robust rust-resistant matte black for the steel flange covers and a vibrant red for the central heatsink pulley to create an impressive visual highlight. Begin crafting the wind deflector blade mold from a flat PVC sheet using a ruler and cutting disc to outline. Use the grinding cutting disc as a template to sketch the aerodynamic contour lines onto the plastic sheet. This process requires meticulousness to create airflow splitter panels with absolute symmetry. Here is the result. A set of directional fins that have been cut, shaped, and sanded for a finished edge. Returning to the pulley hub painted in red epoxy. Use a marker to mark drill points on the 6 heatsink fins. Using an alloy drill bit, carefully drill through the marked points. This part will serve as the central hub. The positioning holes are ready. It's time to assemble the PVC directional fins into the hub slots, tightening them with stainless steel screws. We are shaping the core structure of a Savonius vertical axis wind turbine, upgraded version. Now it's time to reassemble the heart of the system. Place the stator block containing the copper coils into the rear cover and route the 3 cable clusters outside. Next, insert the finely tuned squirrel cage rotor into the magnetic core. The magnetic pull of the steel core needs to be controlled. So the bearing slides smoothly into its housing, then close the front cover. Thread 4 high-strength steel bolts through the flange mounting holes, and tighten the nuts in a crisscross pattern to ensure an even air gap. Place the newly finished core assembly onto the steel support base. It is welded squarely and powder-coated in jade green. Attach the bright red directional hub to the rotor shaft, locking it securely with nuts to withstand centrifugal twisting forces. Reconnect the electrical circuit, temporarily connecting the power phases to the AC grid, to run a test for mechanical integrity. When powered, the directional assembly spins rapidly with extreme acceleration. The motor runs without vibration, demonstrating perfect concentricity. To convert its function from a power-consuming motor into a generator, use wire strippers and crimp a ring terminal, made of copper for the yellow cable. The yellow wire is connected directly to the casing to act as a metal ground. TKE, an AC motor run capacitor, and wire the capacitor in parallel to the blue and red phase wires. This capacitor creates a reactive excitation current, turning the motor into a generator. Now, for the moment of truth. Use a dust blower gun to simulate strong wind pressure blowing directly onto the blades of the aerodynamic deflector. The wind's kinetic energy drives the turbine to spin. Plug a 220 volts AC LED bulb directly into the output. The bulb shines brightly. The asynchronous generator principle works very successfully. The next step is fabricating a sturdy base frame from hardwood.
Measure the mounting bracket dimensions of the generator on the wooden beams. Mark them with a red pen, then use a cordless drill to drill through the located points, in preparation for inserting through bolts. Pre-drill holes in the wood to prevent splitting. When screwed in, the wood will absorb mechanical vibrations well. Screw down the support blocks, ensuring the plastic mounts of the generator fit snugly and do not shift. Use hex screws combined with large metal washers to distribute the clamping force, securely tightening the motor to the frame. Ensure even tightening pressure to keep the system coaxial. Now we move on to crafting the main fan blades. Use a large, thick, walled-up BZ plastic pipe, the specialized type for heavy-duty drainage systems. Measure and mark the precise length. Use a reciprocating saw
to cut the plastic pipe, creating the blank for the blades. Use a U-shaped metal bar as a straight edge to draw a baseline running along the length of the pipe. Use a tape measure to divide the pipe into equal segments. These landmarks are crucial for the next step. Mark each position carefully. From these points, sketch a spiral cut line running along the pipe body. This is the technique for shaping spiral Savonius turbine blades, helping to optimize wind capture from all directions, continuously. Drill stress relief holes at the intersections, using a step drill bit to prevent material fracture. Switch to an angle grinder and cut along the baseline. Continue cutting along the pre-marked spiral profile. The cutting blade glides smoothly over the PVC. After removing the excess parts, we get curved, scoop-shaped turbine blades. Insert a metal tube to serve as the main shaft, and begin assembling these PVC blades. The stack design creates a spiral effect. Screw each blade securely to the central shaft. This aerodynamic structure allows it to self-start in a light breeze. Complete the assembly of the entire wind-catching blade system. The vertical axis design allows the turbine to operate without needing a tail fin. Returning to the generator base, wire the two output lines to a standard 220 volts electrical socket. Tighten the copper contact screws securely to prevent arcing. Close the socket's protective cover to ensure electrical safety during use. All manufacturing stages are complete. We will bring this DIY wind turbine system up to the corrugated metal roof for testing. Assemble the spiral blades onto the generator shaft and place the system in an open area where the wind is strongest. Prepare a high-power LED bulb and plug its connector directly into the power socket from the generator. The wind begins to blow. The curved PVC blades capture the kinetic energy, generating powerful torque that drives the rotor to spin rapidly. The asynchronous generator operates incredibly efficiently. The generated excitation current is enough to brightly illuminate the LED bulb. A fantastic electromechanical recycling project, turning waste into an endless source of green energy.